I'm going to be investigating what happens to the light bulb on the electrical circuit when different chemical compounds are added to the water. I predict that if salt is added to the water with the electrical circuit, then the light bulb will start to glow. When sugar is added to the water, the light bulb will not glow because the physical properties in the sugar compound results in a low electrical conductivity. The variable that I'll be changing is the type of chemical compound. The variable that I'll be observing is the light bulb's level of conductivity, and the variables that I'll be keeping the same is the amount of water and the amount of chemical compound added to the water. To make this a fair test, I'll keep the amount of water and the amount of chemical compound added to the water the same so that the concentration of the solution is consistent for each compound used. Now to get started, firstly place the electrical circuit into the water by using the mouse to drag it. In the concentration box, tick the Show Values box. This is so that you can see the water levels easily and the salt and sugar levels. Make sure there is 0.50 litres, 500 millilitres of water. If not, drag these taps across to either increase or decrease the amount of water. In the solute box, make sure the salt box is ticked. Next, click on the salt shaker and hold the mouse down and shake 0.50 molecules per litre of salt into the water. The molecules of salt can be measured by looking at the concentration box and waiting until the salt bar reaches 0.50 molecules per litre. Observe and record what happens to the light bulb. What is its level of conductivity? Very high, high, low, very low, or none at all. Now do the same process with the sugar. Firstly, remove the salt. In the solute box, tick the sugar box. Add 0.5 molecules per litre of sugar into the water. Measure this by looking at the concentration box and waiting until the sugar bar reaches 0.50 molecules per litre. Observe and record what happens to the light bulb. What is its level of conductivity? When I changed the type of chemical compound, the light bulb's level of conductivity changed. When salt was added to the water, the light bulb's level of conductivity was high. However, when sugar was added to the water, the light bulb had no conductivity at all. The reason for the salt conducting electricity in the light bulb is because salt is an ionic bond. This means that salt is made up of ions formed by the transfer of one or more electrons from the outer shell of a metal atom to the outer shell of a non-metal atom, which causes positive and negative ions. When added to the water molecules pull the salt's positive and negative ions apart from each other. Instead of the ions being right next to each other, they wander all over the water. Water on its own does not conduct electricity as it has very few ions. However, when you dissolve the salt in the water, the positive and negative ions in the water allow electrons from the electrical circuit to flow much better than if you just add water by itself. Because only a small amount of salt was added, the conductivity level was still high. However, the more salt you add, the higher the conductivity level. Also, because there was only a small amount of water used, the salt and water solution was more concentrated than it would be if we were to add the same amount of salt to double the amount of water. Sugar, on the other hand, is a covalent bond. which is why it did not conduct any electricity in the light bulb. This means that sugar is not made up of any ions, but instead is made up of uncharged particles called molecules, formed by the sharing between non-metal atoms of their outermost electrons. When added to water, the covalent networks are very hard to disrupt, and because molecules hold their electrons so tightly, the molecules also tend to be poor conductors. This reasoning also supports my initial prediction made. Fortunately, there were no problems in this investigation as it was digitally investigated and therefore was very accurate. To improve fairness of this investigation, I could have tested more chemical compounds for their conductivity level. However, that option was not available on the simulation. Another investigation that could be conducted could be to keep the amount of water the same as well as a type of chemical compound that conducts electricity, and change the amount of compound added to the water. For example, you may choose to add salt and start with 0.20 molecules per litre and record the conductivity level, increasing the salt by 0.20 molecules per litre each time to make a more concentrated solution, like so. This would investigate the effect that different solution concentrations have on an electrical circuit when salt is added to the water.